a line or a line segment can have slope, but a parabola can't really have a slope. But there is something about a parabola that has slope, which is this. Any point on a parabola, this is the parabola y equals x squared. Any point on a parabola, for instance 3, 9, there is a tangent line associated. It hits the parabola just one point, and that tangent line can have a slope, and finding the slope of that tangent line is an important question in math. And I want to show you how we can calculate out that slope. First, to give you a feel for this problem, we're going to use a method that was developed by someone named Fermat. He said, I can't find the slope of a line if I only know one point, but if I have a second point, in this case it's on the parabola, it's 416, I could find the slope of that. It's called the secant line. Hits the parabola in 2 points. And the slope of that one, 16 minus 9 over 4 minus 3 equals 7. Now, the secant line is not the same as the tangent line, but their slopes are close to each other. So the next idea is, what if I were to pick a point that was closer than 416? What if instead I picked the point 3.1, comma, whatever 3.1 squared is? Well, it turns out the slope of that secant line is not 7 anymore, but that slope is going to be 6.1, and that's closer to the actual answer. And if instead I pick a point even closer, like 3.001, and the y-coordinate is 3.001 squared, and I figure out that slope, it ends up becoming 6.001. And we get the feeling that the actual tangent line slope is going to be pretty close to this, and it's probably 6, but is it exactly? Well, Fermat has a method that will lead to that. For the Fermat's method, I'll use the point 3, 9, and I'll call this other point 3 plus h, where h is kind of like a small number, which makes the y-coordinate 3 plus h squared. This is still y equals x squared. That's a secant line because it goes through 2 points on the parabola. The closer h is to 0, the closer the 2 points are together, the more accurate the answer. When I actually calculate out the slope of this thing, I get y2 minus y1 over x2 minus x1. Now this expression, if I do FOIL, and on the bottom the 3's cancel out, and on the top the 9's cancel out. And on the top I can also factor out the h. Now remember, we want h to be as small as possible. If I plug 0 in for all the h's here, I would get 0 times 6 over 0, which is undefined, 0 over 0. But if I cancel out the h's, and now I plug in, I'll just say is approximately 6, because h is so small. Now, if I do this process for a different point, like 416, and use 4 plus h squared, this happens, and the 16's cancel out, and the 4's do, and just like before, I can factor out the h and cancel the h. Whoops, 8 plus h, to get 8 plus h, which is approximately 8. And what seems to be happening, at least for y equals x squared, it seems like the slope of the tangent line seems to be double the x coordinate. It happened here, 4 became 8. and it happened here. 3 was the x-coordinate, and the answer was 6. I want to show you how to prove that that's always the case. Instead of calling the point 3, 9, I'm going to call it x squared, and the other point is going to be x plus h, comma, x plus h squared. So the slope is x plus h squared minus x squared over x plus h minus x, which becomes x squared plus 2hx plus h squared minus x squared. Those cancel. X plus h minus x cancels. Factor out the h. 2x plus h over h. Those cancel. That's going to be about 2x. So with that, we get a rule that in the parabola y equals x squared, the slope of any tangent line is double the x coordinate. Now, if it's not y equals x squared, but it's something like y equals x squared minus 10, if it's shifted up or down, the rule still holds. So here's 3, 9, and here's 3 comma minus 1. Slope of the tangent is 6. Slope of the tangent is just shifted down, so the tangent doesn't change its slope. So this rule is going to be, no matter what, if I have y squared equals x squared plus whatever, then the slope at x is 2x. I'll write x squared plus a.